Hello everybody, welcome to Marketing Analytics course. This is Professor Shagato Chatterjee from Vijisom IIT Kharagpur who will be taking this course for you. So in the last video we were dealing with a hotel review data set, and what did we do till now? So I have done, so if you see this, I have read the data, get a little bit of idea of the data and then summarize the data, and while summarize the data we use dplyr library. So if you do not have that, you have to install that, and then I created a summary of the data set for the whole hotel, all 23 hotels, and that summary had the overall rating, and that summary also had the mean of the location, service and various other aspects, 6 other aspects. And then we also found out that how I can actually compare my hotel with my competitors' hotel. So we selected 2 hotels from Rourkela by chance, and then we created summary 2. And we were about to create a bar plot of the performance of these 2 hotels. So that is where we have stopped. So while I have started this video, I have actually cleaned my console, cleaned my global environment. So if you are continuing from the last video just now, then you do not have to do all this stuff. But all those guys who are starting this video and seeing this video separately than the probably the session 5 video, then you have to do the same thing that I am doing right now. So clean your global environment, clean your console, set your working directory to source file location again, and then from line 1 to line 21 select the whole stuff, line 1 to line 21, and press run, so that you and me remain in the same page. That is very important as we go ahead. So now that we are in same page, and I have the summary 2 which looks like this, where there are 2 hotels and their overall rating and their performance of each of the attributes has been given. I will actually try to do a little bit more work. So the first thing that I will try to do is to create a bar plot. Bar plot means, bar plot looks something like this. So if I will just clean this first, and so let's say I am planning to create something like this, where let's say for hotel 1 it will look like this, hotel 2 it will look like this, and then there will be a curve, and then there will be, let's say, and the second column will be like this always. So this is, let's say, overall rating, this is aspect 1, this is aspect 2, and this is the ratings, and this is the variables probably, and this is hotel 1 and this is hotel 2, this is the legend. So something like this is what I will be trying to create. Why I have been trying to create this? Because this gives a fairly measurable idea that okay, overall rating wise hotel 1 is worse than hotel 2, and that is majorly contributed by A1, though A2 wise hotel 1 is much better than hotel 2, A2 might not matter probably. That is why this kind of result is coming. So this is something that we are going to create now. So to do that, the code is bar plot, the function is bar plot. So you can go and find out the help of bar plot. How to find out the help of bar plot? You have to write question mark and then bar plot and press and enter, or you can write help within bracket bar plot. So any of these 2 options you can do. So bar plot. So bar plot will actually use a matrix in it. So what I am trying to plot here? I am trying to plot here in the data set, not here, in this data set summary 2, whole this, all this from here up to SRV, everything I am trying to plot. But I cannot give the input. This is something that has been written by somebody, and he has written it that way, that the input has to be either a vector or a matrix. So here, because we are creating a bar plot of multiple parameters, it is not a single parameter, it is multiple parameters. So the input will be a matrix. So I have given the input as matrix. So summary 2 comma, so you will see summary 2 is the data set. Summary 2 data sets, if I just see this much, summary 2 data sets all the row, because nothing written before comma, and 2 to 8, that means leave aside the first column which is the hotel name, and other than that use all other column, that means overall rating to service all other column you use, and then change it to its matrix form as dot matrix. So, if I just click it and print it here, it will be just this is a matrix format. This is the input in the bar plot. Okay. This particular matrix is the input in the bar plot. And what else? It is asking me that when I put the bar plot, what will I write here? So, here I have written OR, A1, A2. So, what will I write in my case? So, that is the names argument, names.arg. Names argument is what? The column names of summary 2. What are the column names of summary 2? If I just write column names of summary 2 and then 2 to 8, so that will give me this column names, because second column to 8th column I am creating a subset of the data set and then I am finding out the column names. So, these are the aspects and the overall rating comes at the bottom of the chart. So, that is how I have created. Then I have also is asked that what is my x label. So, x axis what will be the label? The label is aspects. Y axis what is the label? Ratings. You can give any other name, does not matter. Now, B side is equal to true. B side is equal to true means I have 2 hotels. So, one way of representing it is this, another way of representing somehow somebody can create something like this. So, it is hotel 1, this is hotel 2, this is hotel 1, this is hotel 2, and this is hotel 1 and this is hotel 2, overall A1, A2. So, basically stacked, this one is stacked view. So, something like this, somebody can create, this is a stacked view. So, when you try to create a stacked view, you will write B side is equal to false. When you try to create, do not want to create a stacked view, you will write B side is equal to true. So, I have written B side is equal to true. And color you can choose anything, I have written 5,6. You have to choose 2 colors, there are lots of colors available, you can choose 1,2, it will come black and probably red, and then if you so RBG and so on. So, if I just select these 2 lines, the bar plot line, and run this one, I get here in the plotting area, I get a plot like this, and I will actually make it a little bit broad, and you will see that there are overall rating, value for money, location, sleep quality and so on, and the ratings are coming up, and I can fairly see by seeing this. And if you can probably also want to add up a legend on this. So, legend is x is equal to 2, y is equal to 2 is actually the location of the legend, where x axis and in y axis at what level it will be printed. And what is the legend? Legend is equal to summary 2, 1. So, summary 2, 1, if I just and print out this much, this is nothing but see 2 levels, one is Panthanivas Rourkela and another is Radhika Regency Rourkela. So, these 2 names gets printed and the color is the same color that you have chosen 5,6. So, if I run this also, the legend also, the legends comes here. So, this is a very common thing that happens in R, that sometimes it hangs. So, it is that is why it is a very good practice that you keep on saving whatever files that you are creating, so that you do not lose stuff. Yes. So, what we will do now is that we will create the bar plot, and the bar plot will look like this. So, as I just told that there is a matrix that you have to create, and then the names argument and the x label, y label, and B side is equal to true. So, and color is equal to 5, 6. So, when I run this, it looks like this, and if I just make it bigger, it will look like this, and I get an idea that okay. So, based on this thing I can say that overall rating. So, overall rating I can say that the blue one, I am not telling which one is which, because the first one is basically the blue and the second one is pink. The first one, the hotel 1 is not doing as good as hotel 2 obviously. the overall rating is a little bit lower based on the data set that we have. And I can also say by seeing this particular this thing that okay, so that VFM is more or less same, location is also more or less same. One of the major thing which is not same is cleanliness. So, cleanliness is much lower for the blue guy, and probably the SRV is also much lower, the service is also lower than. So, I would strongly say that the last 4 aspects SQ, RMS, cleanliness and service, these are the 4 contributors. Now, it is very easy to say that cleanliness is something that you can improve very easily, and sometimes if you actually improve cleanliness, it might also have an effect on SQ, that is service sleep quality, or if not sleep quality, at least in SRV, the service, it will have an impact on that. So, it might be a more economical choice that I will focus on cleanliness. Now, other than that, I have to also focus on that which one is more important and which one is less important. This is something that matters. How I will find out that? We have discussed in the previous video that I have to find out that using something called a regression equation, where overall rating will be my y variable and x1 to x6, which is all the aspects, will be my x variable. So, before we run regression, there are certain steps. What are those steps? The first step before you run a regression is that we have missing value. So, missing value imputation is my first step. Then what is the step? So, I will deal with there are lots of ways of missing value imputation. Ideally, that should have been done in that should have been covered in a course called Introduction to Business Analytics. Here I will just follow something called a median imputation, because you see all our observations, you will see later point of time, all our observation is a little bit of I would say bias towards the higher side. That means the more numbers of 4s and 5s are there rather than 2s and 3s and 1s probably in the review. So, it is not symmetric, and if it is not symmetric, probably median is a better choice than mean to when I am doing the imputation, because that will not change the distribution of the data. So, that is something that I am trying to do. The second one is missing value imputation. After that, we have to also find out outliers, because this is a linear regression. All of variables are, let us say, I can assume them to be numerical and continuous, and if by chance I am assuming them to be continuous, we will see that whether that assumption works or not. But if by chance that they are continuous, then there might be outliers, and I have to find out those outliers and remove them. That is step number 2. And step number 3 is basically we have to see correlation. So, at least the x variables cannot be correlated with each other to run a regression. That is also an assumption that we have, and we have to check that whether that is fulfilled or not. And I will stop here. There are other things that you have to check. We have to check for heteroscedasticity, you have to check for variance inflation factor and etc. But today's class is only about how to do it in Excel, in R in an easy format. So, I will not focus on that. So, let us say the first one is missing value. So, what I am writing here, carefully see, for I is equal to 6 to 11. Now, how do I know 6 to 11? Because I have checked the names of data, and the missing values are there in the service rating, the aspect wise rating part. So, those are 6, that is rating value to service rating service. These are the 6 aspects where the NA values are there, and which will be used in my x as my x variable in the regression. So, I am focusing on them 6 to 11. So, for I is equal to 6 to 11. So, here I told that how to what these names within bracket data will come in handy. So, I in 6 to 11, what happens is this I keeps on changing. I takes the value of 6 and then 7 then 8. When I takes the value of 6, data then comma 6, that means the 6th column will be replaced in such a way such that if else means if something happens you do something, if that does not happen you do something other. So, there will be if else, if you remember there are 3 things in if else. In if else there were 3 things: condition, If the condition is true, what happens? If the condition is false, what happens? So, these are the 3 entries that I have given in my if else function as well. So, if else is dot na data $I. So, let us say I is equal to 6. Let us just assume I is equal to 6. Then what will this particular guy give? Is dot na data $I. This guy will give me, see, lots of trues and false. There are some trues in between also and lots of falses. So, it is actually checking out of my 900 observations where the values are na. So, is dot na, whether it is na, like it is asking. If it is yes, it is na, then it will come as true. If it is not na, not missing value, then it will come as false. So, wherever it is true, replace it with what? Median of my data comma 6. So, what is the median value of 6 when I is equal to 6? What is the median value? 4. And when that is not the case, then keep it as it is. When the is dot na is false, we do no changes. So, this particular thing will actually change. It will go one column at a time, find out where the na values are, replace it with that particular column's median value. So, when I do that, I actually replace the everything with the median value. So, how will I know that it has been replaced? Now, if you do a summary of the data, sorry, data will be capital, D capital, summary of the data, you will see there is nothing, no NAs in the last 6. Here when there is a NA, this is actually saying NA, but this is review type, we have not touched that. We have touched the last 6 attributes. There were some NA values, because you have seen that is dot na gave you true in some of the cases, but right now I have removed them. So, here there is no NA coming, here there is no NA coming in any of these things, there is no NA coming. So, that means that all the NA values has been replaced. So, summary is something that I wanted to show. So, that will actually remove all the so it does not remove, it actually shows the basic, I would say, descriptive statistics of all the variables, like what is the mean, what is the median, what is the first quantile, what is the third quantile, etc., etc. So, you can quickly see that in summary. Now, we have done missing value. What is the next step? In the next step, I told the next step is outlier removal. So, remove the outlier. So, how to remove the outlier? So, outlier will be there both in the y variable and the x variable. So, x variables were 6 to 11, but y variable was the second variable in my data set 2. So, I have written when I varies from 2 and 6 to 11, 2 comma 6 to 11. So, 2, 6, 7, 8, 9, 10, 11, these are the values that I will take. Then what I am doing? I have written something, carefully check what I have written. So, one by one. So, when I try to do missing value, I am trying to do outlier. What is an outlier? So, there are various ways to define an outlier. Outlier is a value which is very away from the mean. And how do we decide? If there is an x, which is a variable, long variable, we find out mean of x, which is m, and we find out standard deviation of x, which is s, and anything which is beyond, let us say x is within x is within m plus 3s and m minus 3s, this is not an outlier. 3 is something that I take. If you are a little bit more conservative, you can take 2 as per your wish. So, x, as long as it is within this limit, it is not a outlier. So, I can also write x minus m has to be within minus 3s to 3s, or I can write x minus m by s has to be within minus 3 and 3. That means, I can also write x minus m is what? Actually z, the standardized form, x minus mean by standard deviation. So, z has to be between minus 3 to 3. That means, the mod of z has to be lower than 3. When it is higher than 3, it is outlier. When this is lower than 3, I will keep it. as simple as that. So, that is what I have done here in my code, that I found out the z value for each of the columns, and I have checked that whether that z value is lower than 3 or not. So, what did I do? This part, so let us say I is equal to 2. Then what does this part does? This part, only this part. So, sorry, only this part does is what? It takes data's second column and scale it. Scale it means it changes it to its z values. So, all the values that you are saying there is the second column's z value. These are the z value of the second column, which is overall rating. So, it has turned. Now, I want the absolute value mod of z. So, ABS is the function. So, ABS will give me the same things, but in an absolute form. That means, it will say that all the negatives will be positive and all the positive will be positive. So, see here all the values coming are positive, no negatives, everything are positive. Now, what I am doing? I am checking whether they are higher than 3 or not. If they are higher than 3, it will come as true. If it is lower than 3, it will come as false. So, all those guys are coming false. There might be some trues in between, I am not checking it right now. So, there will be trues and false. Now, I want to keep the false ones actually, right. I want to keep the false ones. So, instead of doing this, let us make it simple. Delete this one, just check what I am deleting. There was a exclamation sign which was not of whatever I was doing in the right side. So, I am removing this and I am putting a smaller than sign. Smaller than sign means it will give me true values when guys are within 3. When the mod of z is lower than 3, it will give me true, and those are the values I want to keep in my data set, because they are not outliers. So, I am putting that. So, this is my A, this is my A, but all the trues means these are all not outliers. So, if there is some by chance some falses in between, then that will be an outlier, and take that subset of the data in such a way that I am taking only the trues and not the false. So, I am taking only such rows where this particular column is coming as to be true rather than false. If it is by chance coming false, do not take the whole row, the whole row you just remove it. So, this is the thing that I am running. So, you stop the video again or go back to the a few steps again in the video and listen and understand what I have done. So, the moment I do that, you will see if I run this particular line, you will see that we had 952 or something like that. From there I got 872, which is a huge drop. So, there will be around probably 80 odd outliers, and we have removed that. The next step is correlation. So, okay, so I have removed that. So, correlation is, so I am only wanting to find out the x variables correlation 6 to 11. So, I am writing that correlation of what? Data is my data set, that data set's 6th to 11th column. So, if I run this, that gets saved in something called Correl. Correl is a matrix. I click on that and this gives me the matrix. And if you carefully see, all the values in the matrix are lower than 0.6. I think so. Just check. Yes, all the values are lower than 0.6. It is coming lower than 0.6. So, there is no very hard and fast I would say multicollinearity issue or correlational problem right now, as of now. And then we have to also check for normality. Another important thing is that all the x and y variables are normal. So, what we have to do is I have to find out the histogram of everything from the x variable, which is 2, and then 6 to 11, all the variables is histogram. And there is something called Shapiro test, which is just go and check, it is a goodness of fit test for normality. So, it checks that whether it is normal or not. There is a W coefficient that it calculates, that value has to be higher than 1. If it is lower than 1, it is not normal. So, if I just run this, you will see that there are so many diagrams that got created, and I will show you one by one. So, the first one is overall rating. This is not normal. it cannot be normal because it is a categorical variable actually 1, 2, 3, 4, 5. Again this is not normal, this is not normal and so on. So, these are the it can be because they are categorical variable they are not normal, but still probably a little bit of up and down is being seen. Now, oftentimes we actually ignore this normality in oftentimes because our major goal is not to focus on the rightness of econometrics techniques. Sometimes our goal is to get an overall a vague level idea that which one is more important, which one is less important. So, sometimes we ignore it in many research papers of marketing, people have ignored the normality part, but you probably should the right practice is to consider it that these are not normal. And if you have checked this thing, you will see that all the W values, I have checked it for all this thing, all the W values are coming lower than 1. So, they are none of them thing is normal. So, ideally if it are not normal you should not do linear regression, but for the for current purpose I will do a linear regression and then I will do something else also which will deal with this particular normality issue. But linear regression is something that most people know, most people have an idea about, those who are doing this particular course probably. So, linear regression, and I will discuss about linear regression in further details in a different class, but here I am just showing you how to do linear regression, which is fit is equal to fit is the value where all the data sets get saved and all the results of the linear regression get saved, and fit is equal to I have written LM stands for linear model, and then within bracket my y variable which is review overall rating and then tilde and then x1 plus x2 plus x3 up to service. So, all the aspects I just write it down, and data is equal to the data set name which is capital DATA coming from here. So, once I run this and want to see the summary of my fit, the summary of the result, I see something like this. So, the call and this is the first thing that I will see that the F statistic and the corresponding p value. The p value is coming 2.2 into this e minus 16 means 10 to the power minus 16. So, 2.2 into 10 to the power minus 16. So, that means 0, 0, 0, 0, 0, 15 zeros after the decimal point and then 2, 2. So, that means very small, that means the F statistics is significant. So, I can believe on this model. Then the adjusted R square is 0.5651, it is good enough at least in the context of marketing, it can be further improved, but as of now it is good enough. The intercept is also coming not significant, that means see how to know not significant, the p value is higher than 0.05. So, I can say that okay, fairly good model, and I can find out, see all this value, location etc. has been measured in 1 to 5 point scale. So, I can probably compare them. Another way of comparing is before you do this regression, you change all these 6 values to their scaled form. So, you change to their standardized form, then you do the regression. So, that might be a better step. Whatever, if you do the regression, I can see from the data set that service is the most important part. So, 0.24 is service and 0.11 is cleanliness and 0.20 is rooms and 0.12 is sleep quality. So, how that matter? If I see now this particular one, so I was doing cleanliness was a bigger problem for me. So, this jump is much bigger than this, but service is twice as important as cleanliness. So, then probably that the weightage that the service gets is much higher than what the weightage the cleanliness gets, and you have to think about that when you are dealing with this thing. And probably in comparison to all the aspects, rooms and service are more or less similar, and sleep quality and cleanliness is more or less similar, and location is the least important factor in this particular data set that I have created. Location is the least important factor. Now, the last step, and this is the step for those people who have a little bit of idea about econometrics and who thinks that linear regression is not a best choice here. What we have done is something called ordered logit. My y variable is 1, 2, 3, 4, 5. So, they are ordered. So, ordered logistic regression is another way of dealing with this. So, what we did is we actually converted all our x variable and y variable to their factor form. So, I took data 1 is equal to data another data set, I have created another data set, and from 2 and 6 to 11 for all these columns, the y column and the x columns, I have written data 1 $i comma I, that means the data 1, the new data set's ith column is the factor version of that particular variable. So, I have changed everything to factor. So, now if you write str data 1, if you want to see the structure of data 1, you will see all these guys were integer, now they have become factors. These guys have become factors. So, the structure says that the new data set has all the x variables as factors. Now, there is a library called mass, in which there is a POLR function, which is actually a function which has been used for multinomial, actually ordinal logit. So, ordinal logit regression OLR. So, fit 1, a new name I have given where all my details will be saved. Everything remains same, instead of LM we write POLR, that is all. So, POLR makes sure that this particular thing, the y variable is a categorical variable. So, once I run this, I get certain result, and I want to show you the result. So, here the p values are not coming, but does not matter. If the t is higher than 2, I can say that it is significant. So, the first thing is, see, the rating value 1 got dropped. This is categorical variable, it is dummy variable. So, one of the dummy variable will get dropped and the other will remain. So, here for the rating value 1 got dropped and the other 4 are there, and you will see that, you will carefully see that in comparison to rating value 1, that means value for money whoever giving is 1. If you by chance improve your value for money from 1 to 2, the overall thing increases by 1.9. If you further increase from 1 to 3, it increases by 3.4. If you increase by 1 to 4, it increases by 4.3. It is not a linear increase, it's a logistic regression, so logistic increase. But you will see that as you go ahead, as you keep on increasing your rating in value for money, the overall rating goes up, and all of these things are significant. Similarly, here 3 got dropped, for location 3 got dropped and 4 and 5. So, anything lower than 3 is not even accepted. There is no review in my data set where the location is lower than 3. Now, for those where the 3, if you go from 3 to 5, it will increase, but you see that jump is not so much, 0.73, 0.9 in comparison to 5, 4, etc. So, then this jump is not so much. So, I can say that location has less impact. Similarly, sleep quality, you will see sleep quality has lesser impact. So, first of all, from 2 to 3 it is insignificant, t value is lesser than even 1. So, it is insignificant. But sleep quality in comparison to 2, when you go to 4 and 5, you make a jump from 2 to 4 or 2 to 5, it increases, but the increase is still at the range of 1, not 9, not 5, not 4, in a range of 1. Then if I go ahead, this is probably a little bit more important because the jump is at a range of 3.4. Here something is very interesting, that if you see that if you increase cleanliness from 2 to 3 and 2 to 4, it is showing that your overall rating will drop. Actually, your overall rating does not drop because your t values are very low. So, these results, the first 2 results are not meaningful, these 2 results are not meaningful, but only when you make a jump from 2 to 5. So, 2 to 3 does not happen, 2 to 4 does not mean anything, 2 to 5 there will be some change which is positive, still it is not significant. So, cleanliness has no meaning as per this particular result. It has no meaning, you do not even focus on cleanliness, whatever happens in cleanliness you do not care. On the other hand, services, it has some meaning, it can be seen when you jump from 2 to 5, the increase is 2.6. So, this guy gives you an idea that exactly if I jump from 2 to 4 or 2 to 3 or 2 to 5 in terms of some improvement in the aspect ratings, how that will impact the overall rating. So, that is why our in this particular video what we did thoroughly is we have read a data set, we have grouped the data set and get certain insights, we have created a bar plot next, then we have to do a regression. What are the steps? We find first remove the missing values, we then found out that whether there is any outlier or not, we remove the outliers, and then we actually found out that whether it is a normality test are done for the x variables and the y variables, and we did not find them normal, but still we actually tried for linear regression, we got good result, good insight, and we also did ordinal logit and we have got some bit of idea. Now, till now I just wanted you to show the coding, not linear regression, not ordered logit. We will actually focus on each of them specifically at a later context. Here I wanted you to actually get a little bit handy with the coding, and that was our purpose. This is all that was there in week 1. Week 2 onwards, we will actually come into the marketing problems and we will use various tools. Again, I would suggest at this point of time, I would suggest that if you have studied statistics for management, the basic statistics, you should go and revise that, that is number 1. If you have studied marketing management, basic marketing management, you should go and revise that. And if you have studied, let us say, introduction to business analytics, some of the concepts of regression, if a little bit of machine learning techniques, if you have ever heard about them or if you have ever studied about them, it is the good time to revise that. Because in our classes, we will actually combine all of this stuff in solving marketing problems, and it is a prerequisite, it is a expectation that you might have a little bit of idea about marketing management, probably statistics and introduction to business analytics. So, this is the right time to go back and revise all of these things. From the next session, which will be week 2, we will actually focus on all of this stuff to solve marketing problems. Thank you for being in this particular video, thank you for being patient enough, and we will see you in the next video.